The easiest thing to look at if you want to understand what's going on is pure YAML. And I'm going to fight anybody who thinks differently.
This is DevOps Paradox, episode number 229, the evolution of installing applications into Kubernetes. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, in 2014, Kubernetes landed. Does that sound about right?
Sounds like that, yeah. That horrible thing that nobody could run, yes, at that time.
Couldn't run it, but then we were finally to the point to where we could run it. Sort of. But then we had to figure out how the heck do we get our applications installed to this beast of machines?
Yeah.
Do you remember Helm 1?
Helm 1. I did not know that there is more than one.
Well, there was a version of Helm that you couldn't use just by itself.
Helm. Sorry, I misunderstood.
Helm,
I thought you're
Helm.
talking. You said YAML 1.
No.
Is there
Helm 1.
Helm 1. The thing with that tiller thingy, horrible thing that I've intentionally forgot. And I'm not going to remember it again.
I guess we should actually rewind here for a little bit because that actually wasn't the first thing. So what we're going to be talking about in this episode is how installing applications into a Kubernetes cluster has sort of changed over the years. And we're saying over the years, it's been 7 years. Like it's been a really less than a decade, right? It feels weird, but how did we do it at the beginning? Because even before Helm, by the way, do you remember who wrote Helm?
I don't. Who wrote Helm?
I'll give you 3 guesses, and the first 2 don't count. And it was a company that was run by a man named Gates.
Microsoft? Yes, yes, it was Microsoft. Yeah, exactly. You're right. It's coming back to me now. Yeah.
This is sort of proving the point that we're going to get to a little bit later. Helm isn't the way to do it in 2023. Just keep that in mind. But let's go before Helm. What did we have to do?
Write YAML and then send it to Kubernetes API.
That sounds a lot like punch cards.
Now, the trick is that we are still doing exactly that. And I feel that that's where many people misunderstand the purpose of those tools. It's always YAML or JSON. And it goes to API as YAML or JSON. All that we do with tools is many great ways how we can convert something to YAML before it goes to Kubernetes API. That's all that. Actually, that's wrong. There are 2 purposes of those tools. Let's use Helm as an example, and then we can extrapolate to others as well. 2 purposes. One is to convert something into YAML. The second purpose is to give you some additional features when querying your cluster for stuff. Like, I don't want to see all the deployments and services and ingresses. I want to see all the Helm charts running in my cluster. But Helm chart just happens to be yet another Kubernetes resource, so you can do it with kubectl get charts or whatever is the CRD. But nevertheless, yes, it's those 2. And the second one, to kind of manage cluster a bit better, I would ignore that because I don't think that that's the core purpose of those tools. And if I'm right and we ignore those, the only thing that they do is figure out how to convert something into YAML.
And that's it.
That's all they do.
That's the key part to all of this, right? That's the key part to all of this is we are submitting a YAML to the Kubernetes API.
Exactly. So some people, and I had those discussions actually 2 months ago, maybe something like that, with some people in a conference, and they thought that when you execute something like Helm install, you're sending a Helm chart to Kubernetes API. And you're not. You're not doing that at all. What you're doing is convert the template into YAML, send it to Kubernetes without you knowing that those are the 2 steps. I mean, there are more than 2, but 2 important steps. That's all it does.
Once you understand that, then all of these things become, okay, then which tool do I want to use? So initially, here's the YAML file, submit it, have a nice day.
My first usage of such tools was not Helm, and I'm not sure now whether I'm talking about Kubernetes or Docker days, but it's more or less the same, right? Because in both cases, YAML goes somewhere. The first tool that I used, what do you think it was? To help me manage YAML as end result.
Probably your editor?
No, YQ.
Oh, YQ. You're right. Didn't think about that.
I was doing that actually. I would have my manifests, and then every time I would need to change, the thing you change most of the time, depending on the environment and this and that, would be tag of the image. Doesn't matter whether we're talking about Docker Compose or we're talking about Kubernetes. What do? You cut that YAML, then pass it to YQ, and then pipe it to some command. Docker Compose, kubectl. That's the first iteration of my first usage of such tools before Helm. I'm not actually sure whether it was YQ or JQ. Anyways, one of those.
Well, in theory, it should be YQ, but back then it could have been JQ because I can't remember when YQ showed up. Okay, so you did that, all YAML. Then we started getting tooling because people got tired of working with 20,000, 50,000 line YAML files.
Exactly. They got tired of running YQ.
Okay, fair enough.
I still use it. I still use it more often than Helm. YQ is awesome.
It is. But let's sort of go through the process here. So people thought they needed a templating language to make this simple so that 50,000 became 50. Right?
I don't think it's that much reduction in the number of lines, to be honest. If you look at Helm templates of any application, doesn't matter whether it's first party or third party, you don't get less really lines of something. I don't think that's the goal. You just get more things that you can dynamically modify or more values that you can change and more bigger parts of or more parts of that output that can be included or excluded, right? So we're talking about value substitution and conditionals mostly with a touch of loops. So I could probably say that value substitution, conditionals, and loops represent 99% of the use cases that those tools do. With value replacement being probably the half of those 99% or more.
But that was the key part there, was the value replacement. Your way of doing that was YQ prior to that. But looking at a values YAML file is much nicer than actually looking at the effective manifest that's being built.
Definitely. Sorry, manifest being built or the commands to build a manifest? The easiest thing to look at if you want to understand what's going on is pure YAML. And I'm going to fight anybody who thinks differently. I will always be much faster figuring out what's going on by looking at the final output in YAML than through templates. You go to a template and then you read in first, second, third line, and then, oh, there is this value. Excellent. Let me go to the values file and find out what is the default value at least. Oh, and then you say, okay, that was easy. And then you have a conditional. And then you, okay, now if this and this is true and this is false and I don't know what and how, then I get this snippet included, right? From the observability perspective, from I want to understand what's going on, there is no easier thing than the final output. The one sent before it's sent to Kube API.
Well, that's what I meant by effective or rendered or whatever. That's what I meant by that. But yeah, I agree. You want to see what the final product is to understand what's going on.
Exactly.
Because Helm templating, although wonderful and can save you a lot of time, is one of the most miserable things to write known to man.
Yes. Even though there is Helm 1 and Helm 2, and Helm 2 is basically complete rewrite of Helm 1, but I will put them in the same bucket for now. It's the first attempt to solve the problem. And how often the first attempt to solve a problem ends up being the best way to solve the problem. It might be the most used. I'm not talking about Helm, but in general. Because of the sheer inertia and, the first mover get the adoption and then people don't want to change and all those things, right? That all is true and happens very, very often, no matter the technology we're talking about. But name 3 things that were the first in its specific sector of the industry and you would say, yeah, that's the best solution years later.
I can't think of a single thing that falls into that bucket.
Exactly.
Okay. Raw YAML, which is what it always is. Helm 1 with Tiller, which was insane.
Nightmare. Exactly.
Then we got Helm 2, which is still current.
No, Helm 2 is following that logic that I mentioned before. Helm 2 literally, when you execute a command, it transforms it into YAML and sends to Kubernetes API. While Tiller had some nasty things that it was doing inside the cluster to convert this to that and stuff like that. But Helm 2 falls into that bracket. Yes, the output is YAML.
And, of course, you love Helm 2.
More than Helm 1, if you want a politically correct answer, without offending anybody. So it's much better than Helm 1, yes.
So we've had people ask us this before, and I want you to restate your answer. If you are building an application that is for you, not for third parties, not for customers,
yes,
should you be creating Helm charts?
No.
And why is that?
There are a couple of reasons. First, when it's third party, Helm chart. First of all, Helm charts are great for third party because it's a golden standard. It's the de facto standard. Most people are using it, so everybody expects it and all that jazz, right? But I'm going to ignore that. What does matter is that it's a very, very different game depending on whether it is third party or first party. And the major difference is in the number of variations you need to put. So let's say any third party, let's say Jenkins, right? Jenkins serves tens of thousands or hundreds of thousands, or I don't know what the numbers are, a massive number of people, right? And when you provide the Helm chart for it, you need to accommodate all those diverse needs, right? Someone will have it like this, someone will have it like that. Someone needs enabled this, someone needs disabled that, right? So the number of variations is great, is big. Now, when we're talking about first party, the number of those variations is infinitely smaller. Simply, the number of permutations that you have is essentially the number of permutations that you have between different environments. I'm going to greatly simplify it now. I know that it's more complicated than that, but hey, the tag will change from one case to another. Now, if you're using Helm, you should be updating Helm chart with your tag so that always it matches the specific version of a chart. It has tag baked in, but okay, change the tag. Whether it's going to have horizontal pod autoscaler or no, or whether it is going to have this number of replicas or that, whether it's going to have things that are available in production, like maybe service mesh is running only in production, and when you run in local development environment or remote development environment, you don't have service mesh, and so on and so forth, right? There are variations, but there cannot be many of them. Now, counter argument I get for that, no, but our application has 5,000 different settings. Yes, but those are the default values, right? They do not change. Nobody changes 5,000 settings for their own application. I would go as far as to say that if you're not in low double digit, and I'm being very generous right now, in the things that you change between environments, you're doing something, on a single application, you're doing something terribly wrong.
That sounds very much like a monolith inside of Kubernetes at that point, if you have that many switches.
But, even if it's monolith, yes, you have things that you might need to tweak, but most of those tweaks apply everywhere, and then I don't count that as value, just to clarify. I mean, you can put it in values file, right? But that's unchangeable. I'm talking about things that change from staging to production, from development to staging to production. How many things change between those three environments? Especially now, and here comes the important part, which is kind of indirectly related. We work hard, I believe, as industry to externalize many of the things that had to be inside applications, right? Like certificates, we were managing from inside the code of the application. Or in a slightly better scenario, they were baked into containers or what's not, right? Or mounted. Now we don't. That's outside. Service discovery. How do we find out what I need to speak with and with whom I speak depending on where I am? Again, service discovery. Figured out. It's happening outside your application, so on and so forth, right? So many of the things that were inside before and resulted in those 5,000 different doors and knobs and what's not, they're now out. And now we're truly talking about what is the difference between staging and production. And there cannot be anything more than low 2-digit. And I'm being generous now.
If you had more than 30 or 40, 50 tops, boy, you've got a lot going on.
And 50 is already, I'm freaking out, but okay.
Yeah.
Let's go for it, right?
I mean, what would you have? You would have a URL, a domain name. You would have a database connection of some sort.
Maybe, not necessarily.
Or pointing at an
okay.
object, right? I mean, again, that's discovery, right? But you
Yeah.
at least have to understand what the discovery is.
Let's go for it, exactly. Let's say
Right.
it, yes.
I'm saying is if you can set your app up to where everything's discoverable and your values are discoverable, then you have one item.
Tag.
A tag, and that's it.
And number of replicas, one way or another, right? Because you don't
Right.
want to add
No, that's
production size in other environments. I mean, there's more, maybe memory and CPU, right? Kind of like what you need in production. It's not. There are things you want to change, but it should be low number.
So raw YAML, Helm 1 tiller, Helm 2, which we'll just call Helm from this point forward. But before we move on, you know what would solve all these problems that we're talking about?
Customize.
Which we'll get into.
Wait. Is it going to be spicy?
It's going to be very spicy. What we have here is our friends at Barbaro Mojo are sponsoring today's episode. Are you ready to spice up your life while you change how you install applications into Kubernetes? So Barbaro Mojo brings the heat with their unique Cuban marinade base, adding an unforgettable flavor to your favorite dishes. With flavors like El Habanero, Halibo, Panazzo, and Best Day Ever, there's a perfect match for everyone's taste buds. As a DevOps Paradox listener, you're entitled to an exclusive 25% discount on your first order. Just visit barbaromojo.com and use the promo code DevOps25, that's DevOps and the number 2 and the number 5, at checkout to claim your discount. The link to Barbaro Mojo is down in the episode description. Thanks to Barbaro Mojo for sponsoring today's episode. So we've gone through the big three. Raw YAML, I was going to say HTML, and that's not right. You'll get back raw HTML if you hit the API endpoints wrong, which is sort of strange.
Actually, when you're describing Helm, you're describing raw HTML. Or no, HTML template.
Correct. Yeah, so I messed up. But anyway, okay, raw YAML, Helm 1, Helm 2, and then you mentioned it right before the break, customize.
Yes, I do not know whether historically what appeared exactly what timeline, but you can say that customize came after Helm, at least in adoption. And customize is a conceptually completely different way to do things. So instead of templating, you're talking about overlaying. You're saying, hey, this is my base YAML, and I'm going to overwrite it with this YAML. And that kind of works once you figure out that, first of all, it doesn't work for third parties. Completely breaks. So I'm going to ignore that. But for first party, it works because YAML is a data language. And this is important for this conversation, right? YAML is not a free text something. It's a data structure. We define the structure of data and we put values into that structure. That's what YAML is. There is nothing beyond data structures and values. And that means that you can overwrite once. You know the path to every single thing, right? Okay, it's spec, parameters, this, ingress, this and that, right? Kind of, it's a tree-like structure of things. And that makes it very easy to overlay. Say, okay, so follow this path and replace this thingy, right? Instead of adding special things into YAML that is not YAML anymore, which is what Helm does, right? I would be much more positive towards Helm if Helm came up with YAML templating, but it didn't. It came up with, it's the Go templating that we use for text or HTML, right? It's completely oblivious that it's trying to template something that is data structure. And customize is having completely opposite direction. Kind of, okay, we recognize that this is data structure with data. How about you just write that structure as is, and then we are going to figure out how we can replace things with some other things.
If you do not believe that YAML is a data structure, leave out a space.
I mean, not only, just to clarify, the same story would apply to JSON, the same story would apply to XML, right? They're all data languages.
They're all data languages, but the spacing makes a difference in YAML where it doesn't make a difference for the other two.
Of course, I was more referring now to being data language,
yes.
Right?
Yes.
Or the way to describe the structure of data.
It's a way to interchange data between two systems.
Yeah. And yes, free text, I mean, just spaces alone, right? I don't remember anymore. It's been a while since I wrote Helm template, but there are special commands to say, now indent all this by 4 characters. Come on. What am I doing here? What does it mean?
So customize, big thumbs up for first party, definitely not a third party tool.
Yes.
You don't want to. Now, if you had taken in a third party app and you're now making it first party, I'd still be careful.
If you make it first party, meaning that I will never, once I do whatever I'm going to do, I'm never going to depend on that third party anymore for updates and so on and so forth. If that's the case, I would say just don't. Don't. You want to benefit from, that's why we use third party. We want to benefit from other people and other teams and other companies actually providing us value. Not one-time value, but continuously, right? With improvements, patches, whatever that something is. So just don't.
So again, going back to the top, big raw YAML, you were doing YQ and whatever other tooling. But at the end, you were responsible for all the YAML.
Yes.
Helm showed up, and you set it there by using Go templates, just like, by the way, what's used in Hugo for doing static site generation, is what's used to generate the final YAML. So a step in the right direction. But the flaw in Helm, if you want to call it a flaw, because it's not, it depends on the use case. But the overall flaw in that is it's not treating the YAML as a data structure.
Correct.
It's treating it as plain text that happens to be formatted in a specific way.
If you execute Helm template, which is what behind the scenes is happening, right? So when you say Helm install, you can think of it as, I'm executing Helm template, which actually converts template to YAML and then doing kubectl apply. That's what Helm install in a nutshell is, right? You can actually do Helm template command, and if your templates contain something that is not YAML, it will still fly. It will happily do it.
Until it doesn't, right?
Until it doesn't. So you will not find out that you're doing something wrong until Kubernetes itself tells you, no, hey man, you cannot do this. Please don't. This is insane. You're missing spaces over there.
Then customize, which is the preferred way for first party. But then we had Flux and Argo CD show up.
Yes.
Which is, forgive me to anybody that was working on Flux and Argo CD, it's a variation of the Tiller story. From the point, hear me out, that it's in cluster.
Yes.
That's where I'll stop with that. I mean, that's just the end point.
From that perspective, I didn't think about it that way until you said it, but yes, it's a variation of Tiller in a way. My analogy before was more like this is actually chef and puppet, variation of chef and puppet, but yeah, Tiller would work as well, right?
And explain the difference between chef and puppet in case people were fortunate enough to never have to work with either of them. Nothing against them because they saved us tons of time.
Oh man, I don't remember the differences, but it's been a while. But I do remember that you can set up at least one of those running in a server, pulling from a source control. At that time, probably SVN, correct me. And then whatever is there, it would run reconciliation to actually make that something happen, right?
One was pull, one was push.
Okay, I forgot about that already.
You could do that.
No. But Puppet
they both had
pull,
agents,
right? But then they changed it. Both have agents, but they all added, if I remember correctly, means to actually do push as well.
Correct.
Kind of probably under the influence of Ansible at that time.
Which is where I was going to go next. So if you were to compare everything we've been talking about, and if you've been in that space, Ansible has always been push only, no agents, agentless. By the way, I love agentless. That's just me. Whereas Puppet and Chef had agents running, but then that gave you the ability to do other things. But now in today's world, we don't want to be running Helm install or kubectl apply or whatever the customize with a K in case you're wondering. Actually, it's a plugin now for kubectl, right?
I mean, it was always, for a long time, it was part of kubectl, but it's been for a long time, kubectl had a very, very old version of Customize. There were some problems how to actually upgrade customizing kubectl. Anyways, now it's just part of, instead of -- file name, you put -- customize and that's it.
Right. Shows you how often I use it. But now, we don't want to do any of that. We want to go into a Git repository, update our tag, and that's it, right?
You still need to do all that, meaning that, so there are still two different, very distinct choices, right? How you're going to define something, and that can be pure YAML, Helm, or Customize, and other tools that we didn't get to yet, right? And then how you're going to apply that something. And then, so Argo CD and Flux, they compete more with Helm install command than Helm template, right? Even though Helm template is in a way part of Helm install, right? Or let's say kubectl, right? Argo CD and Flux compete with kubectl. Instead of us executing kubectl or Helm install, we just push to Git and then they execute it for us. This is where we are coming to the probably the biggest, even though not so known difference between Helm and Flux, right? Sorry, did I say Helm and Flux? Flux and Argo CD. they treat those things very differently in terms that Argo CD Argo CD will not actually manage your Helm charts or customize something or any of those things. It will convert that to YAML and then apply that YAML to Kubernetes. While Flux, and I'm simplifying it greatly now, has a Helm controller which will execute Helm install. So Argo CD would be Helm template kubectl apply, while Flux would be Helm install directly, right? With all the good and bad things of doing that. And in a nutshell, the good thing is, in defense of Argo CD, is that Argo CD treats directly with Kubernetes resources, not with Helm charts, customize what's or not, right? Converts them into Kubernetes resources and knows exactly what is in your cluster and what is the status of all that something. While Flux does Helm install, doesn't know what's inside of the chart, doesn't care much about what's inside of the chart, doesn't really track the output of running a Helm chart, but just running a Helm chart, which is negative from the tracking perspective, but positive in terms like, hey, you can do Helm LS in your cluster, managed by Flux, and you will get all the Helm charts that are running in your cluster. With Argo CD, there is no Helm LS. Helm chart never got to your Kubernetes API. I forgot why am I talking about it, but
so basically we went down this full path because we were talking kubectl apply before. So there was kubectl apply, which turned into sort of Helm install. And then the operational side of that has changed to Argo or Flux, which
correct.
Pick one. Just use that today. Don't do it by hand anymore, right? Just use one of those tools. So I wanted to say that for last. I messed up, but that's okay. What we're really trying to talk about now is really the Helm template side of things. So raw YAML, Helm template, but now, and then customize, really. But then from that perspective, what are the new hotness that you've been looking at on those?
For the rest of the story, until you tell me otherwise, I'm going to ignore the Helm install. I will guess that it's all about Helm template. Helm converts chart into YAML. YAML goes to Kubernetes, right? So the real question that we're asking now is not what is the final output. It's always YAML. The real question is what is the format or the language we want to write that something. What is the easiest way for us to write, right? And we got Helm templates, which is free text templating, oblivious of YAML or any data structure of any sorts, customize, which is pure YAML with overlays. And then we got, and again, I'm not necessarily going chronologically, we got additional languages like JSONnet, which is JSON on steroids, which has certain features. I'm not using it heavily myself, but I know that some people love it. We have YTT from Carvel, currently VMware, which is another attempt to create data-specific language. And among the big ones, it would be Q. Q is all the hotness now. And when I say hotness, meaning 5 people using it in total, but it's hot. But many more speaking about it. Type of stuff, right? So what we are really discussing, I think, is what is the language that suits you best to define data? And I look at it that way more than Kubernetes-centric way, because whichever way you format data, that data can easily be transformed to whichever format is needed for the destination, right? There is nothing technically preventive in us from writing data in XML today, right? I can easily I can have a tool, if there isn't one, that converts XML into YAML. So really we need to pick the first choice is, do we want pure YAML or we want some other language? And I'm putting Helm templates as language there in that category. It's a different language, which it really is. And then we get competition like JSONnet, Q, and probably quite a few others.
Why would I want to use Q versus just writing the YAML?
So I believe it depends on the complexity you have, right? For first-party I still stand by me saying that customize is the best choice for first-party apps, right? It's pure YAML, YAML in, YAML out. All the variations are defined as few overlays. There aren't 200 of them. Easy, right? Why would they complicate anything? And if I have much more variation, first I start to think whether I'm doing it right. Sometimes you do have complexity. And if you do have complexity, then we start thinking about, okay, so this is too complex for pure YAML. What is the language we want to use? And Q sounds like just type of the language. It understands data structure. It's a data language. It is JSON based, and it's mixed with Go. It takes a while to learn it, right? But so I often get the question, hey, I don't want to learn another thing. And to me, that's perfectly valid. But then if the situation is so relatively simple that you don't want to learn another thing, then you don't have a complexity and you can just as well go with a simple solution, which is customize or even pure YAML, right? And if the complexity is such that you need more, then I would say that complexity justifies learning the best format to do stuff. Generally speaking, right? And this applies just as much to Kubernetes manifest as to anything else. And then we have, I forgot completely. And then all the programming languages, right? You can use Pulumi to use the language of choice, whatever languages are supported, and among other things, generate YAML. You have CDKs, again, language of choice, generate YAML. So the question is, what is the format you're most comfortable with? Now, and here comes the important thing. And I'm switching the gears into this is sufficiently complex that something simple does not work, right? I'm excluding simple things here, right? I still make a distinction between what is the best way to write code for this time, because YAML is programming language just as any other, right? What is the best way to write this something? But this is not necessarily the same as what is the best way to find out what that something should be. No matter what we to choose, Helm template, YTT, Q, maybe Q with Imoni, JSONnet or JSONnet with Anka, whatever we choose, right? Or write it in Go. I still prefer the output to be stored and observable as YAML. So any of those tools, I will execute Helm template and push it to Git and then let Argo CD synchronize. And I will execute YTT command, whatever is the command, transform it into YAML, push it to Git, let the tool synchronize. And I will do the same thing with Q, right? So, because when somebody goes there and says, Victor, what is the definition of the application that we want to have right now? I direct into YAML instead of that somebody going through the pain of understanding all the variations and all the conditionals and all the loops and all the variable substitutions to figure out what is supposed to be running somewhere. So there is a difference between what is the output and what is the best way for a person or a team to write something that will generate that output, including the option to write it directly in the format of the output.
Well, it sounds like you would prefer to have, going back to the very beginning, the 50,000 line YAML in Git and be done with it.
Yes. I mean, none of those tools is really reducing the number of lines.
Well, that's the key part that we really haven't said out loud until right now. At the end of the day, going back to 2014-15, it started out as YAML, and in 2023, it's still YAML. And guess what?
Exactly.
In 2033, it'll still be YAML. That is not going to change.
Exactly. It's only a question of whether we want to write it directly or we want to have a tool that creates it for us.
If your use case is simple enough, write the YAML, maybe. Don't go to Q to begin with. Look,
No.
Don't go to Q to begin with. It's you, unless you already know Q. Unless you're one of the 5 people that know Q, Don't go to Q first. In that case, go look at CDKs or Pulumi, because you probably know a language, whether that's TypeScript, Java, Python. There's APIs for those available for you now. Would I do that today? I probably would. Me, personally, because Java's my language still of choice. Yeah, you can make fun of me all you want, but...
No, but perfectly valid. I think it's great. If you feel comfortable in Java, why not use Java to define things? Assuming that the rest of the people who are responsible for, together with you for that something, feels comfortable as well, right?
And also know Java. And that's the key
exactly.
part. That takes us back to
you
the
wouldn't
key
feel
argument.
comfortable if you don't.
Right. You don't want to say, hey, I want to go learn, we'll use Go. Like I've always wanted to learn Cobra to write my own CLIs in Go. But for most people, they are not wanting to learn a new framework if they are not a Go developer. So don't go off and go rogue and decide to go do a new language that when you leave, somebody else has to support. That's a bad idea. Pick the language that is normal for your team or the team that will be maintaining it long term.
The only thing I'm asking from you, let's say hypothetical, you are going to write it in Java. I think that's great, right? I'm just asking you, for the sake of everybody else, to output it to YAML so that I do not need to go through hoops to when I want to find out what you want to run through the hoops of figuring out Java. Not because Java is complicated to figure out, but because, you will write classes and functions and what's or not and if-else statements and stuff like that, and that are going to affect the final output one way or another depending on the input parameters, right?
Correct. The key part to this is we want to have a data interchange between things. There's no programming language that defines data interchange. Except you did say YAML was a programming language. I disagree with you on that, but this is already going on too long. We'll agree to disagree on that, at least at a high level. But what we can agree on is that is a data structure, and we should be talking data structures, not programming languages. Because if you wanted to pull that in, and you'd written something in Q and you wanted to manipulate it some more, great, I don't care. Again, as long as you put it back out as YAML.
So let's put it this way. I want everything that deals with state, and when I say state, I don't mean database state, but I mean state of the system, to be declarative. That's what I want. And Helm is not declarative. I mean, the moment you put if-else statement, it's not declarative. At least not 100%. HCL, even HCL is not 100% declarative, right? I want 100% declarative format of stuff. And I don't care how you get there.
I don't care if you have to go use JavaScript and Java and Go and TypeScript. As long as it ends up in a declarative format that can then be slurped up by something else, go for it.
Correct.
Doesn't matter.
Exactly. And this is, I think that we as industry did not really explain that well. When we talk about declarative and imperative, it sounds like when I say, the state of resource Kubernetes cluster should be declarative, that means that you should write it in a declarative format. I'm not saying that in any form of way. I'm saying just that you should output it and hopefully storing it in declarative format. And hey, if you like Perl, go with it.
Nothing wrong with Perl. In fact, that will manage data probably better than anything else. Here's the key part to this. Whether I'm running a program and it outputs to, in this specific case, a YAML file, or I've opened up my VS Code and I've handcrafted an artisanal YAML file. It has that nice little leaf going through it like a good coffee does. And I do Control S or Command S if you're on a Mac. Those two YAMLs should be the same.
Exactly.
And that's all that we care about. So, again, we came around full circle, even though we actually never left the circle. It has been YAML all along. And will probably always be YAML unless there is a Kubernetes 2.
Yeah, at least for Kubernetes, it's always YAML. I mean, most of the things today are represented as YAML, and eventually we'll figure out a better way to do it as well. So I'm not saying it will always be YAML, but right now it is always YAML.
We still have fixed length file formats going between banks. I think we won't be moving off YAML anytime soon. Okay, anything else? Is that our walkthrough of applying and creating things for Kubernetes resources?
Yeah, I think that's it. The most important thing, the message I wanted to say or send is it always ends up being YAML whether you see it or not. That's the point. Helm install is YAML. You just don't see it.
And thanks again to Barbaro Mojo for sponsoring this episode.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.